Good morning, everyone. This is part of the 4C Emerson webinar series. Today we'll be talking about loss of containment. This presentation this webinar fits in as part of a series about digital transformation. Digital transformation is a part of the response to the Biden administration and environmental groups concern about concentrations and impacts on communities surrounding facilities. So in order to reduce the concentrations within the community, you have to reduce the concentrations of fence line and then reduce the concentrations at the plant. So all of these digital transformation technologies help reduce emissions, improve safety, and reduce cost and increase the energy, improve the energy intensity index. So all of these digital transformation technologies, of which there's an entire suite of these technologies, about 20 technologies within the Emerson package, and this three-part series will go through a few of those. The 4C conference, there will be 8 hours of coverage of the additional offerings. And again, those are all tied into the digital transformation. They all meet the criteria of reducing emissions, improving safety, and saving money. So yes, and these technologies, they all have some similarities in terms of the old technologies are based off of regulatory requirements, which are really heavy on physical inspections. Those physical inspections require someone to go out into your plant. That means, one, you have more people in your plant. Two, there's exposure issues. And three, they're not getting that data for 45, to 180 days. Whereas the digital transformation based off of measurement and sensing drives real-time responses. Those real-time responses, in other words, finding leaks, finding reliefs from relief valves, finding problems with heat exchangers, all of those things, when you find those in real time rather than 45 or 180 days later, you reduce the emissions immediately, which means, of course, you also get the cost savings immediately. So the digital transformation age is sort of centered around the measurement and sensing, which very much facilitates the reduction in emissions, reduction in fence line concentrations, and improvements in environmental justice. So this digital transformation is all a very forward-looking protocol, and it also really connects with young people. Young people like the digital age. They like the digital transformation. The refining, petrochemical, oil and gas industry has a existential need to connect with young people, and a lot of these digital transformation technologies, if they're implemented and properly communicated through the public relations channels, social media channels, they have a means of changing the public's view of the refining, chemical, and oil and gas industry. In addition to the fact that all these things reduce emissions, improve safety, and save a lot of money. So with that, I will turn it over to the Emerson team.
Great. Let me just open with show you the topics we're going to discuss today. So we're going to discuss. Doug's going to go through tank safety solutions and corrosion monitoring, and then I will talk about fire and gas, hydrocarbon leak detection, and pump monitoring. So these are all solutions that we have, digital transformation solutions that we have that can be applied. So with that, I'll take it to you, Doug, and you can start with the tanks.
Okay, thank you very much. The first time I worked in a refinery, I had a summer job at ExxonMobil's Baytown refinery. And during that summer, there were two major tank fires in the plant. Second one involved a hexane tank that was in the middle of the refinery. It was an old tank and it was struck by lightning and caught on fire. And it ended up shutting down about half the refinery because they couldn't drain the tank. They couldn't get a pump on it to be able to pump the liquid out, and they had to let most of it burn. They did actually bring in a famous person in industry, Reddit, to actually go in and connect up a temporary line to a valve position on the tank and open up a temporary line that allowed them to drain out a lot of the hexane. So I was very familiar with tank accidents, and certainly they can cause a lot of problems and explosions. And they are responsible for about 12% of the tier 1 and tier 2 safety incidents in refining and petrochemical, according to the data of the API and the AFPM. So certainly this is a very important topic, and Emerson has devoted a lot of attention and investment to this area, which we're going to talk about. Next slide. So again, as I said, they have large inherent risks. They, there's most of the tanks are relatively thin wall, and so there's an issue about protecting against either overpressuring or vacuums in a tank. There are definitely environmental and personnel hazards in overfill. In the case of venting from a tank, there's an issue of flame propagation and other things. So next slide, Ed. So this lists the four major areas that we are concerned about for tank safety. First of all, blanketing and vapor recovery. So you need to, in some cases, have inert gases that are blanketing the tank. You also, today, instead of venting to atmosphere, as that hexane tank was, you want to have vapor recovery from the tank so that you can actually recover the material and not have the emissions that would go out with tanks venting to the atmosphere. There's emergency protection. Again, we talked about the tank explosion, and so flame arresters are very important on the vents from the tank to make sure that there's no flame and back propagation into the tank. Overfill protection, again, that's one of the major causes of problems in tanks. Actually, Marsh and McLaren, it's an insurance company, estimates that about 1 out of every 3,000 tank movements results in an overfill. I find that to be kind of a high number, but it certainly reflects the fact that this is an important protection. So we're going to talk about that. And then, of course, corrosion protection to prevent against corrosion. So all of these areas are areas where Emerson is invested and has a lot of equipment available to help ensure the safety of the tank. Next slide. So again, on the pressure side, if we look at that kind of center large band of statements with regard to the pressure control band, normal, and then venting, if the pressure goes too high, we have venting and emergency venting. And then if the pressure goes too low, we can have in-breathing, or in other words, bringing in oxygen from outside, or hopefully bringing in some kind of vapor that is inert that we use for tank blanketing. All of that requires equipment to control it. And so that equipment is available from Emerson. Next slide. So this is talking about flame arresters, and that can, of course, lead to a catastrophic event. There have been many that occurred in an industry, and they have had extremely high costs of correction, and also can involve injury and in some cases even deaths to individuals. So we have a set of flame arresters that are there. And one of the areas that Emerson has been investing in for the past few years is diagnostics on its devices to make sure that we know that the devices are working properly. So these devices are all equipped with this diagnostic information. In the second area, they can also be installed wirelessly, so you don't necessarily have to pull wires to be able to put the equipment in. So those two advances, the diagnostics and the wireless, have really increased the capability of the equipment and reduced the cost of implementation. Next slide. So, of course, again, measuring the level of the tank is very important. There are many different technologies that can be used for level measurement, and Emerson has almost every one in their portfolio. So we have, non-contact radar level gauges and many other types of measurements of level. Now, one of the things that has happened over the past few years is API 2530, which is a new standard which indicates that there should be two independent overfill devices on tanks. And so that means that you need to have protection and second protection against that. Now, in spite of the fact that 2530 came out, I don't know, maybe 10 years ago, we still find many, many tanks in plants that do not have redundant overfill protection. So this is certainly an area where we want to make sure that we are compliant with these standards, and that we have the basic protection that occurs with this redundant overfill protection. So also the third area is proof testing of the devices. Now, proof testing in the past meant you had to go out physically to the device and exercise it to make sure it was working. And that is recommended in the recommended practices for tank installation. But now the proof testing is integrated into the device itself, so you can do the proof testing from the control room or from a local control room to check how well the devices are working. Next slide. So, okay, suppose you think there's a problem in your plant and you want to assess whether or not you are meeting current standards. Well, Emerson has a procedure called a tank farm walk down, and we have very skilled personnel who are experienced in all of the regulations and all of the type of protection that you can have in a tank. They will come out, identify the surveyed tanks, go look at them physically, and actually check to make sure that they are up to date on all of these specifications. And it turns out that this, of course, is very important to do from a safety point of view, but it is also can very much result in savings of money. These are a couple results listed there. Nitrogen cost savings at one plant were $500,000 a year, and another plant about 40% reduction due to improved regulator performance. So this, in addition to safety and environmental issues, can actually result in economic savings as well. Next slide. So corrosion monitoring. Next slide, Ed, please. Okay. So the number one cause of tier 1 or tier 2 loss of primary containment is piping or equipment failures resulting from corrosion. So this is a very important issue, and of course, when that happens, that can result again in a catastrophic loss of equipment and products, and very expensive, a very expensive safety incident. Next slide. So here is some data from the API and AFPM safety database. And again, it kind of confirms, if you look at the left-hand circle, you can see that the largest part of the circle is the area of internal piping corrosion for problems, okay? And if you look at the right-hand side circle, you can see that the point of release, again, piping systems are the #1 point of release for Tier 1 and Tier 2 incidents. So again, both of these just emphasize the fact that identifying corrosion early and avoiding it is a major contributor to process safety. Next. Well, what can you do different? Of course, we've been measuring corrosion for many, many years. You have put coupons into the line and you go up periodically and examine them to see what the corrosion has been. But what has happened is the ability to move now to real-time corrosion measurements and be able to use those real-time measurements to save yourself some money by reducing overdosage of corrosion inhibitors and avoiding process issues downstream, which can occur from too much inhibitor, and being able actually to adjust the feed to the refinery to maximize capacity based on avoiding corrosion. So next slide. So in terms of corrosion, what we have available is a very comprehensive set of corrosion measurements. Of course, standard coupons can be used. We have inline probes that can be connected and used for remote measurements. On the right-hand side is the ultrasonic thickness measurement, which can be installed in almost any given area in the plant and communicates wirelessly. So it does not require any wiring to be brought to that thickness measurement. So that has been extraordinarily popular. It's installed in almost 50% of the refineries of the world and in many, many chemical plants as well. So it has hundreds of installations and has proven to be highly successful in identifying local corrosion. Next slide. But the measurements are only part of the story. Of course, you can see here on a column where we might have various sensors installed. Now, what are we going to do with that data? Well, we have to have connectivity. So as I said, these communicate via wireless HART to a gateway, and that then goes to some analytics that keeps track of the metal loss on that particular installation, and also provides then an ability to predict when you might start to have problems. One of the key things here is in the lower right-hand corner. If in the past, when you were talking about new installations, you had to talk about weeks or months because of the necessity of getting drawings made and engineering approved and wiring pulled in the plant. But with these kind of installations, we can have something installed in a very few days, up and working and checking corrosion at an important part of the plant. Next slide. Okay, you said, well, but corrosion is really kind of a slow process. So why do I need to have real-time measurements? Well, it's normally slow, but it's not always slow. If you look at the chart that's shown there in the upper right-hand corner, you can see that the corrosion rate is changing, and these dashed lines indicate different crude feeds that were in the plant. And you can see that the rate of corrosion changes with different crudes, but there was one particular crude mix that resulted in a highly accelerated corrosion rate, something that was measured in the matter of weeks rather than months. So you never would detect that with a standard inspection. You require real-time measurements to be able to catch that problem and take corrective action. And you see corrective action was taken, and the corrosion rate dropped back to its normal rate after that. So this is an illustration of the value of going to real-time measurements. Next slide. Again, this was kind of a very an interesting installation. This is 4 parallel amine absorber trains that were in a plant. And the client decided that they wanted to check the corrosion in the plant. And so they put, you know, the wireless corrosion monitoring on the major areas of corrosion in these plants. And it, to their surprise, one of the amine units had a dramatically higher corrosion rate than the other 3. They were all the same material, you know, they were the same design. So why was this occurring? So anyway, that led them to go through an investigation, and they discovered that there was carbonic acid attack occurring in that due to a high CO2 content in an off gas that was going to that. So they were actually able to take mitigation to reroute that stream to actually to the point where it was not any causing accelerated corrosion any further. And had they not detected this, there might have been a failure in the equipment in that particular amine unit prior to the next turnaround and inspection. The corrosion rate was that much higher. So again, there are many examples of this where monitoring the corrosion has shown real value in detecting potential safety problems. Next. So these are 3 examples of the use of this technology. First one was on an alkylation unit where they were concerned that they might have to take a shutdown early because of suspected corrosion in a rerun tower bottoms. They were actually able to go in and install this device on that tower bottoms and be able to check the metal thickness to the point that they were able to delay and avoid an unscheduled shutdowns. A large Midwest refinery was able to run much higher tan crudes, which were a lot cheaper. So they increased their differential on those crudes by about $10 a barrel. And they were able to do that by putting in corrosion monitoring to help them ensure that they weren't causing excessive corrosion with the high tan crudes. And then in another plant in Germany, again in an amine unit, they detected the fact that they had amine foaming occurring, and it was being carried overhead in an emulsion and causing excessive corrosion in another part of the plant. So they were able to detect that problem and stop it from actually causing a problem that would result in the unit shutdown. Next, Ed, I think it's to you at this point.
Yep. Okay, thanks, Doug. There's some echo there if you want to go on mute. Okay. I'm getting echo. Okay, that's better. All right, I'm going to talk about fire and gas and then a couple other topics. So let me advance. So in the fire and gas area, you know, there's a lot of risks, obviously, in this area with pressurized toxic and combustible gases, and there's a lot of methods that have been deployed over the years. There's many different detection methods, personnel monitors, fixed point detection, but a lot of these traditional methods have a lot of limitations and can put personnel and property at risk. So we're going to talk today about some things that we've been doing to get past those limitations. Okay, so in the conventional methods, there was a study done back in 2008, and it showed that for fixed point detectors, there are many different releases that do not get detected. In other words, the detectors may not be in the right spot, or the wind is blowing a certain way, and the detectors do not pick up the releases. So the whole idea would be you have to keep putting detectors in more and more and more to get full coverage, and that's the area that we've looked at in using various technologies. So, like I was saying before, the gases during a leak, depending on the configuration of the plant, the wind, the layout of the plant, the gas cloud could be in very different ways where detection may become difficult. So there's a lot of factors involved in that. So here's some of the different methodologies for gas detection. So source monitoring, where you put a detector close to the potential leak source, is one. Volumetric monitoring, which is a grid where you put several detectors over an area to monitor. And then perimeter monitoring around the side of the plant. So what you don't detect with a point monitor, you would detect on the perimeter. And then wide area monitoring, utilizing detector coverage in a larger area. So all these different types of sensors get put into a system. You then manage the data coming in, and then activate alarms or provide information to the control center in terms of that. So what we offer at Emerson, our methodology is to provide multiple technologies to get better coverage. And so here's a couple examples. There's I think this is a compressor station, and then there's there's also some spheres there, tanks, and you can see that there are multiple different sensors on there. There's flame sensors, particle monitors, gas leak detectors, open path detectors monitoring around, and then fixed point detectors as well. So the combination of those various sensors allows you to get better coverage and better alerting to a potential problem with a release. And then on the tanks as well, on the spheres, we have open path, flame detectors, and fixed point gas detectors. So what we found as a result of this is you're able to lower the amount of sensors that you have in the field. The whole idea is to reduce the amount of point sensors that you have using these perimeter sensors and get full coverage of any potential leaks and gases and so forth. Okay. So we've done many of these projects. We typically will work with the clients to figure out what is the right strategy to use in a distinct location. So we have field service people that can come out and advise the best way to apply these various technologies. Oops. Okay, and then in terms of results, here's three different examples of results. First one's a chemical plant. Point detectors didn't give enough coverage, and then so what the client did was install both point detectors and open path detectors to get better coverage measurement of gas releases. So that worked well for that client. Another one was reducing maintenance costs. This was a cracker complex. And we put in point infrared sensors with open path to increase the detection efficiency at that plant. So we were able to reduce the amount of point detectors and reduce the maintenance required at that plant. And then Shell, that's a hydrogen storage facility. We installed the INCUS to improve leak detection in the area, and then both PAP detectors and fence lines as well. So got better coverage through that. So we have various experts that can come in and help you apply these different sensing technologies. Brian is on the phone, and if we have questions at the end, he can answer some as well. Okay, so that's the gas detection. The next one is hydrocarbon leak detection. Okay, let me build this here. Okay. So leakages are obviously a very big issue. I met with a tank farm manager once at a large refinery in the Midwest, and he said to me, I said, well, what's your biggest, what concerns you the most about your plant? And he said, leaking something onto the ground in the tank farm. That's my biggest concern, is leaking something onto the ground. And so, there's various levels of leakages. When there's a large leakage, it's easy to detect and find that. But seepage is a huge problem because things can be leaking very slowly in a plant and be undetected for a very long period of time. And so these issues can come up at the plants. So this is what I was saying about the seepages, is that this can go on for a very long time, and basically undetected. Things like mass balance and other things, you won't be able to monitor these very small leakages that happen. But then over time, these can build up, and then you can have an event like a fire or something like that as a result of that. So OSHA and EPA regulations have been the subject of lawsuit settlements and fines at a lot, and consent decrees at a lot of plants. So these are very large issues, and putting in solutions to monitor leakages can prevent these things from happening or from getting out of control. So our solution, let's build. So our solution is a combination of digital wireless technology and then point sensors that can go in the various applications. So you can put these in drain pans, in connection points that may leak, or around specific tanks or pipelines in locations where you think you may get leaks. So because these sensors are wireless HART, it's very cost effective to install them all around the perimeter of the plant. And so the installations don't have that high cost that we would have had in the past. So this technology allows that. All right, and then in terms of results, we've got 3 different ones here. Major refinery in France, 18 tanks, 3 redundant wireless HART networks, 52 transmitters connected to these cable sensing and point sensors. So you can see this plant, this tank farm, has pretty complete coverage from the picture. At BP, they're looking at tank spills. they weren't monitoring hydrocarbon leaks around the tanks and valves and flanges. So they installed this solution, this non-intrusive solution, these sensors around the tanks and the wells and the pumps, and they've been able to improve as a result of that. And then Middle East, the leak detection solution for 19 road crossings and 6 kilometer of pipelines across 3 refineries. So they installed a leak detection system with 100 different sensors and 3 gateways throughout the plant. And you can see on that one, they documented their cost savings in doing this versus a wired solution. So very significant cost savings to do that project with these wireless sensors. Okay, so that's our leak detection, and then pump monitoring. So this subject's about monitoring pumps and auxiliary seals. There's a API standard RP 682. Hydrocarbon pumps, you know, so you have these dual seals on pumps that can fail, and when they fail, you lose the reservoir, and then you know, so typically people today are monitoring these seals manually. So they're doing manual walk-around inspections, and so you're going around, you know, once, whatever the frequency is, once a month, once 2 months, checking out these pumps and the seals on these pumps and looking if there's an issue. So there's a lot of risks because you're not monitoring these in real time as process conditions change. Okay, so in terms of the recommendations, traditionally pressure switches and high level switches and low level switches were used on these seal pots for the pump seals, and then the switches would activate when the level went high or low on the seal pot level on the pumps. So you know, these seals can fail. So if you're just walking around and looking at them, if process conditions change in the plant, manual monitoring may not be enough, and then that can lead to very serious consequences from that, explosions and so forth. I mean, we read about these things all the time where pumps, mechanical seals fail on a pump, and then you have leakage, and then you have a fire. So the new solution that's being recommended is to use pressure and level wireless sensors on that seal pot, so you can more accurately monitor the pressure and the level in that seal pot, and then detect online any anomalies that would occur that would cause a problem. So that's the solution. So that uses the wireless technology then to transmit that data back on a more frequent level than an old manual monitoring system. Okay. So here's when we look at the pump, there's several different things that can be monitored on the pumps, and then so we also have vibration sensors that can then monitor cavitation, bearing faults. So we talked about the pressure and the seal fluid level, temperatures, and then I also spoke about leak detection. So we can put together some of these technologies or all of these technologies on pumps, depending on the risk level. And then we have a pump application through our PlantWeb software, PlantWeb Insight, that will allow you to look at those pumps, and it'll give you analytics and alerts to determine any potential issues that come up. Okay, so that's more about the PlantWeb software. So cavitation alerts, seal failure, seal pressure and level, and full analytics. So these analytics can be put to your cell phone as well. So you could have an alert of any pumps in a unit if you're responsible for an area. or from a PC as well to monitor the health of all the pumps out there. And then client results, we've done a lot of these around the world. One of the first ones that we did, I was involved in, was at Citgo Lamont. We put in wireless devices to do the pump health monitoring and analyze that continuously. Another North American one on a coker. We put in a wireless network, temperatures, pressure transmitters, and a gateway, and then notify the operators when the filters need to be changed on those seal systems. And then the last one's talking about vibration data for pumps. We put in Emerson wireless vibration transmitters and installed continuous data to the reliability people. So it would give them an early alert to a problem that they might have in the plant. All right. So that was everything we had for today. I went through that very quickly, but if there's any questions, okay, so to get back to us longer term, you can email me, or you could go to our website and click Consult an Expert. We will also be at the 4C conference in August in Austin, Texas. So our subject matter experts will be there and would be happy to work with you on any of these solutions. So do we have any questions or comments?
Well, I think good. Thank you very much for your time, Ed. Very informative presentation.